So on this example, we have a polynomial function that's below. That's f of x equals -8 times x plus 1/2 squared times x plus 3 cubed. And for this polynomial, we want to list each real zero and its multiplicity, determine whether the graph crosses or touches the x-axis at each x-intercept, determine the maximum number of turning points for the graph, and determine the end behavior, that is, find the power function that the graph of f resembles for large values of absolute value of x. Okay, so conveniently, this function is written in a factored form, so identifying the real zeros, which are the same thing as x-intercepts, it's very easy to do that in factor form. So we can take each factor, set it equal to 0, and solve. So we have -1/2 being 1, 0. We'll take this other factor of x plus 3, set it equal to 0, and solve. And we have real zeros, which are x-intercepts, of -1/2 and -3. So our zeros are -1/2 and -3. We also want to identify the multiplicity of those zeros, and the multiplicity of those zeros can be found using how many times those zeros are, or those factors are repeated. So because we had a factor of x plus 1/2 and another factor of x plus 1/2, we say that -1/2 has a multiplicity of 2. And we have x plus 3 times, x plus 3 times x plus 3 times x plus 3. That zero has a multiplicity of 3. We can use this multiplicity to determine the behavior at that x-intercept. We can determine whether the graph crosses or touches the x-axis at that x-intercept. So when we have an even multiplicity, that tells me that the graph will touch the x-axis at that point. And when we have an odd multiplicity, the graph will cross at that point. Then in this next part, we want to determine the maximum number of turning points. In order to determine the maximum number of turning points, we have to know the degree of this polynomial. So the degree of the polynomial we're going to get by how many factors on the variables we have here. We have 2 factors on this one and 3 factors on this one, so we have 5 factors of x. That's going to give us a degree of 5. So then, once we know the degree, the max turning points is always going to be 1 less than that degree. So the maximum number of turning points would be 4. So then our final part here is to determine the end behavior of the graph. So to determine the end behavior of the graph, we want to pay attention to our leading coefficient here, as well as all our variable terms. So if we apply the power to the variable and then multiply, we're going to have a leading term of -8 x squared times x cubed, and that's -8x to the 5th. So our power function for this graph is going to be -8 x to the fifth. And just to give you a little bit more detail about that, what that means for end behavior, we're going to look at two components of this leading term. You can look at the degree and the leading coefficient. Now the degree is odd, and what that tells me is that the ends are going to go in opposite directions, one negative and one positive, where it might be positive on the left, negative on the right. But then when we focus in on the leading coefficient, it tells me which one. So it tells me this one right here. Meaning that on this side of our graph, where x is near -infinity, our y will be positive. And then over here on the right side of the graph, the y will approach -infinity. Thank you for checking out my videos. Have a great day.